This is very simple problem based on NMR spectroscopy. The H1 NMR spectrum of HD consists of HD is nothing but deuterated hydrogen molecule. Instead of H2 we have HD. One hydrogen atom is replaced with deuterium. The given options are singlet, 1:1 doublet, 1:1:1 triplet, 1:2:1 triplet. It is very simple. In no time you can solve this problem. The first thing you should know is deuterium is NMR inactive. You will not get any peak for deuterium. Only H1 is NMR active, so you will get peak only for this. For H1, the I value is off. For deuterium, the I value is 1. You will get signal only for hydrogen. At the same time, this signal will be splitted by deuterium. You may know the formula. It is calculated by the formula 2Ni plus 1. To find out the multiplicity, we use this formula. N is the number of identical atoms which split the signal. Here I have only one deuterium, so N is equal to 1. What about I value? I value of deuterium is 1. What I get is 3. So I get triplet. Based on that, I can eliminate two options. Now what about the intensity of the triplet? Whether it will be 1:1:1 or 1:2:1. 1:2:1 will be like this. You may be very familiar with this kind of signal in NMR. What about 1:1:1? That will be like this. All the three peaks will have same height. When the splitting atom is hydrogen, generally we get 1:2:1. For example, let us consider ethyl acetate. This signal will be splitted by these two hydrogen atoms. If you substitute in the formula 2, N will be 2, I will be off for hydrogen, and what we get is triplet. So these three hydrogens will appear as triplet. What will be the intensity? The intensity ratio will be 1:2:1. For ethyl acetate, you can find peak like this. It is calculated by using this triangle. When you have only one hydrogen, you will get doublet and it will be 1:1 ratio. When you have two hydrogens, the ratio will be like this. 1, when you add these two, you will get 2 and finally 1. So when you have CH2, you will get 1:2:1 intensity ratio. When you have deuterium, this triangle will be something different. You will get like this. When you have one deuterium, you will get 3 peaks with same intensity. Suppose, say you have 2 deuterium atoms. In that case, you will get quintet. There will be 5 lines. And the intensity ratio will be 1, 1 plus 1, 2, 1 plus 1 plus 1, 3, then 2 and 1. When you have 2 deuterium atoms, this will be the intensity ratio. Here we have only one deuterium atom, so the correct answer is triplet with the intensity ratio 1:1:1.